This is a walkthrough of Problem 1 on Practice Exam 1 of Module 11 in the book Problem Solving Guide for Mechanics and Thermodynamics. A circular aluminum pizza pan has a radius of 8 inches at a temperature of 20 degrees Celsius. It's placed in an oven at 180 degrees Celsius. What's the change in the area of the disk? Because it expands. The area of a circle is pi r squared. They want the answer in units of square inches. So let's look at a pizza pan. It's always good to have a diagram. This might seem like a diagram is not much help, but at least we know the diameter is not 8 inches, right? We're going to look at that and we say, oh, it's the radius, that's 8 inches. We don't have a formula for delta A, only delta L, but that's all we need because the radius starts out at 8 inches and it increases in length by delta L, and delta L is alpha L delta T. Alpha for aluminum, 23 times 10 to the minus 6 per degree Celsius. This was on the test. We have L, 8 inches, and we have the temperature change. It started at 20, went up to 180. That's a change of 160. This is the change in the radius. So now we know what the radius is after it heats up. It's 8 plus that, 8.0331 inches. If we know the radius, we can calculate the area. The area of any circle is pi r squared, so we stick in the new radius and we calculate the radius of the heated pan, the area of the heated pan, 202.73 square inches, and we can stick in the area room temperature pan, the radius is 8 inches, and we can calculate that's 201.06 square inches, and we can subtract the 2 to get the change in area, 1.67 square inches. That's the answer to the question. This is a significant amount of area, right? You might have been surprised. 1.67 square inches, that's a lot of area. The radius only changes by 0.0331 inches. That demonstrates the importance of the O and the I in FOIL. And let's see how that works by using calculus to get the answer. The area of any circle is pi r squared, and we want to know the response to the area when we change the radius. What's dA? When we change the radius by dr. This is what calculus is all about. Differential calculus. When the radius is different by dr, what's the area difference? So here's the original area, and we have some more area because we added some more radius. This is the formula for the area of a circle. The area, the total area, is this, and that's pi times the radius squared. It's just a different circle. It's got a little bit more area because the radius is a little bigger. So now we're going to FOIL this thing out. FOIL the right-hand side out. So we have an r squared, we have a dr squared, and then we have the two cross terms, which is 2r drs. The original area, A, is pi r squared. It's just right there. So we can cancel that, and we can get dA. dA is pi times 2 pi r dr plus dr squared. We can plug in dr to get dA. There's our equation. Now, I'm really not supposed to do this, all right? Differentials, dr and dA, are not numbers. They're just ideas. They're infinitesimal. They don't have a value. But I understand calculus, and I'm going to stick in numbers, and I know I shouldn't do that. Don't tell on me. So here's my equation. These should really be deltas instead of d's. Instead of differentials, I should put a delta there. So here I plugged in everything. 2 pi r dr. There's my change in r. There's dr squared. And I get 1.664 square inches plus 0.003 square inches, which is 1.67. In calculus, we just drop this dr squared term. And we should do that because it's infinitesimal. We shouldn't be plugging in values for it. It's infinitely small compared with dr. So this makes the derivative 2 pi r dr. We throw out this term. We throw out our dr squared term. Now, if you've taken calculus before, and somebody asked you to calculate the derivative of pi r squared, you might know it's 2 pi r dr. Because there's some rules. But let's look at dA to see if we can understand where it comes from. So here's dA. My pan got a little bit bigger. I heated it up, and now there's the extra area. The change in area is dA, and that's 2 pi r dr. Let's unroll this thing. Let's cut it right here and unroll it into a rectangle. There it is. How long is that thing? Well, it's 2 pi r. It's the circumference of the circle. How thick is it? It's dr thick. What's its area? Well, it's base times height. 2 pi r dr. Now you understand where the differential comes from. That's problem 1.